Alright, hey guys, it's Miss Scott with your notes today. This is meant for Miss Scott's Earth Science classes for Friday, May the 5th, 2017. If you've stumbled across it and you find it helpful, well, yay for you. So today what we're going to talk about are trends in climate change. So to reiterate, yesterday we talked about the factors that influence climate, like why are there polar climates near the Arctic, and why do we have a moderate climate here in North Carolina? Well, it's a variety of factors, including latitude, how close you are to water, your elevation, and your geography, where you are relative to mountains and things like that. So today we're going to look at how climate, which again, remember, are long-term patterns of weather, how we see these changing over time. So the things that we are going to consider today are temperature, sea ice, sea level, and ocean pH. You should have a note outline. If you don't have that, I would suggest you get that and follow along with it. The note outline is a little different today. You have, instead of just filling in blanks, you're going to be asked to answer questions as we go through. So answering questions based on what you see on the slides. So let's start with natural changes in climate. We're going to first begin with the greenhouse effect, which I know we've talked a lot about, but there's actually a little bit more to the story than we've talked about in the past. So we know the greenhouse effect is a natural phenomenon where energy from the sun, either visible light rays or infrared waves, are trapped by certain gases in the atmosphere. So we have talked primarily about this type, positive greenhouse effect, and I don't want you to think about positive as in being necessarily a good thing, even though that's what that word sort of implies. What it means is that heat travels back, which results in a positive increase in temperature. Negative greenhouse, so this would be caused by things like methane buildup and CO2 buildup, which we get from fossil fuels. It lets visible light in, and that's all fine and dandy, but it's trapping the heat. The negative greenhouse effect is sort of the opposite, in where infrared rays, because they because of their wavelength, they're able to bounce back. They're able to bounce through these particulates in the atmosphere that are blocking visible rays. So here, negative, again, don't necessarily think of it as bad. Negative simply means that the temperature drops. So here in your notes, you have your diagrams labeled. These are how how positive greenhouse effect and negative greenhouse effect are different. All right, positive is what we experience, what you probably think of. Heat, IRs, infrared, is trapped, leaving warming. Negative greenhouse, visible light is blocked, but heat can leave. This results in cooling. An example of this that you're probably familiar with, we all know that approximately 65 million years ago brought an end to the age of the dinosaurs. A series of natural events, including meteor strikes, volcanic eruptions, things like that, threw dust and particulate matter into the atmosphere, which blocked out the sun, which resulted in this mass cooling, which the dinosaurs were not adapted to, hence why they're not here anymore. All right. Here are some examples of greenhouse gases. Again, all of these, water vapor, CO2, methane, nitrous and nitric oxides, and ozone, all of those lead to positive greenhouse effect, so visible light can get through, but it's the heat that is trapped and bounces back to the earth, and this results in warming. Now, there are natural processes that introduce all of this into the atmosphere. The big one that we're worried about, though, is carbon dioxide. Remember, with human activity, especially in the United States, most of our energy is produced from non-renewable resources like coal and oil and natural gas. And all of those things, when they burn, they release a fair amount of carbon dioxide, which is why we want to invest in alternative energy sources that maybe don't necessarily produce as much carbon dioxide if we want to mitigate our impact. Right? So, we're experiencing the positive greenhouse effect right now in our lifetimes. That is going to influence sea ice, all right? Sea ice is found in polar regions, so that would be near the North Pole, the South Pole, Antarctica, the Arctic, all that good stuff. Now, you might be like, well, I don't live near the North Pole. Let's say you live in Florida, or your family's from Florida, wherever. Like, that's a long ways off. Well, this sea ice is going to have a tremendous impact on everybody, even though itself, like, nobody really lives here. All right, so let's look at how sea ice influences climate. Sea ice has what's called a high albedo. Now, those of you, if you're taking Latin or you studied like stems, you might recognize this ALBE, alba or alba. That stem means white, which is the color of sea ice. Basically, things that are white reflect light. So sea ice reflects light, which is great. But with our positive greenhouse effect that we got going on, and the fact that it is being amplified by added carbon dioxide, added greenhouse gases, the ice is starting to melt because it's warmer. Well, once it warms and the sea ice is gone, now the oceans are going to absorb more of that heat, which is then in turn going to melt more sea ice. So it's what we call a positive feedback loop. Something happens and that causes a chain of events which makes that event happen even more, which is not good. All right, so sea ice helps drive the global ocean conveyor belt, which we talked about with ocean currents. That is how heat and nutrients get around the globe. What I want you to do now, if you're in my class, I'd like you to take a moment to pause the video and go to these links here. You can find them in the just the regular PowerPoint version of this presentation. And I want you to watch these. They're a couple minutes long each, and see what would happen if all the sea ice melted and how would that impact you. Oh, goodness. All right, when you're done, come back and we'll continue. All right, so pause video. All right, and we're back. So hopefully you saw with sea ice melting, we would lose a lot of habitable space. Most people live by the coast. And we would have a disruption of that global ocean conveyor belt. So let's carry on our discussion about how climate change impacts the environment with ocean pH. We've already touched on this with human impact. We know that increased carbon dioxide levels leads to the acidification of the ocean. That extra CO2 in the atmosphere gets absorbed by the ocean, making carbonic acid. Here in this diagram, you can see this is a reef where you have 375 parts per million of carbon dioxide, and the water temperature has been increased 1 degree above normal. And you can see it's still pretty healthy. You got some fish, you got some corals. It's all good. Yay. But as that increases, so here's 450 to 500 parts per million, and the water temperature is up 2 degrees Celsius, we have a lot less life forms here. Not as many corals. There's probably some little fish hiding in these little crevices and whatnot. But here, at above 500 parts per million, and water temperatures rising over 3 degrees Celsius, basically the reef is completely lost. You can't form corals because they have those soft calcium structures, so they can't build themselves up, which means that those animals that rely on them for food and shelter can't live there either, right? And the last thing we'll talk about with trends in climate change is a natural phenomenon called ENSO, which stands for the El Nino Southern Oscillation. Basically, it's not a storm, it's not like a one-time thing, it's a shift in weather patterns over several months or years. All right, so generally these last about 4 years, not 4 years, they last a year or so on average, and they range every 2 to 7 years. Now, what's interesting is that over the past several decades, the frequency of El Niños has increased. Instead of seeing these, 7, 10-year gaps between events, we're seeing 2 and 3-year gaps. What happens here? The trade winds stop. Now, the trade winds normally push water. They flow from east to west, so from the western coast of South America towards the western Pacific. And because these trade winds stop, the surface temperatures get much higher, 3 to 5 degrees Celsius on average. So again, this is an opportunity for you to see. This is a 3-minute video from National Geographic about some of the impacts of El Nino. I want you to watch it, to pause this video, watch this video, and answer the 3 questions that you have on your note sheet. When you're done, come back and we'll continue. Alright, now that you're back, alright, let's go over, make sure you got the questions for the El Nino video. In what way does warm water move during an El Nino year? During an El Nino year, warm water moves towards South America, towards the western coast of South America, so eastward. In normal conditions, water would be pushed westward. Upwelling, how does El Nino affect upwelling near South America? Upwelling is stopped. And remember, upwelling is that bringing up of cold water, that nutrient-rich water. So if you stop that upwelling, you don't have the nutrients you need anymore. You can't have a food chain. And in western South America, because you have, in the western part of the United States, because you have this warmer water and these warmer temperatures, during these El Nino events, the weather's going to get warmer and it's going to get wetter. There will be more precipitation. So you get these crazy floods and mudslides, and it's a hot mess. All right, now moving on to La Niñas. They're basically the opposite of El Nino. So if you know what an El Nino is, you know what a La Nina is. They're less predictable, so they don't have the same sort of frequency of El Ninos. Here, instead of the trade wind stopping, the trade winds get really, really strong. And the water temperature, especially at the coast of South America, gets a lot colder. So you have lots more upwelling. Because of these stronger trade winds, right? Beep. So here we have a diagram of a normal set of circumstances and El Nino circumstances. How to compare La Nina and El Nino are right here, which can go for that in your notes. Yay! All right. The last 3 slides are review, so let's review again. Pause the video wherever you need to, go back wherever you need to. During an El Nino event, weather conditions along the western coast of South America will be warmer and wetter, or wetter and warmer, or hotter and more precipitation. However you want to phrase that, associate that with El Nino. Here's a review, not from this PowerPoint, but from the one yesterday. Which city will heat up quicker in the day and cool down more quickly? Seattle or Great Falls? Here's Seattle. Here's Great Falls. Great Falls will heat up quicker and cool down more quickly. Why? It's not because it's getting more or less sunlight. It gets about the same amount. There's no big body of water around Great Falls. Remember, if you are a city along or near a large body of water, that's going to regulate your temperature a little bit more. You'll have warmer winters and colder summers. Right? And all the ways that melting polar ice could impact the globe, explain each in your own words. I'll leave that to you, and we will discuss this on Monday. If you have any questions about this presentation, just leave them in the comments or write them down. Make sure I get them on Monday. And You all have a fantastic weekend.